All right, some warm-up, product chain rules, integration, an indefinite integral number 2, and then just a limit for number 3, all right? It is supposed to be 3. Yep, the limit, and that's a good question, because usually I've probably screwed it up. But everybody, that's what we got going on. So, on the first one, you have to see it's a product rule. I said do not simplify.
Hey, Mr. Anderson?
Yeah.
Before I forget, since tax season's starting.
All right, so everybody, you got f prime g plus g prime f. For sure, when you start this problem, the red one, you have to realize it's going to be a plus sign in between the two things. I'm going to pull out.
Did we just do this one?
Yeah, I'm recording now.
Oh.
So everybody, I start by doing the first derivative, which is 3x squared times sine squared 2x. All right, plus, then I leave x cubed alone, and then I do the derivative of this, which is going to be, first of all, a power rule, bring down the 2, times, now it's a chain rule, derivative of sine is cosine, and then the derivative of 2x is 2. So I got to put times 2 at the end of this. And everybody, this is an unsimplified answer. All right? And if you're not seeing the parts, I show down here my selection of f and g and my derivatives, f prime and g prime. I do not typically do this, all right, any longer. Everybody, number 2 is an indefinite integral. There is no value here, right? I'm not finding the area under the curve because I didn't give the limits of integration. So 2 things you know right away. You're going to find the antiderivative, and it's going to have to be u-substitution. And you know your answer's got to have plus c on it. So for sure, when I start this off, I'm going to fill in the blank, and I know it's got to be the answer plus some constant, because we don't know where in position it is. So our first step here on this problem is to set our u. All right? Our first step is to set our u. I think our u this time should be what's in the radical, and it's typically that. And I immediately, without any thought at all, do the implicit differentiation of this. All right? And now I start to look for substitution patterns. Everybody, this is going to be u, right? And if I'm going to integrate u, I need du. But the problem right now is I don't have 3x squared dx. I have...
Is that where you put the 3 outside the s?
You put the 3 there, all right? Because you need it here. What has to go outside the integration sign?
1/3.
1/3, right on, Calista. Because the red third 3 is still 1. And you can multiply any expression by 1 and not change it. So now by doing that, and I get rid of this, whoops, that line's all one thing. But I'll put the 3 back. Now, hopefully you can see that this is right here, right? And that's du. And this is u. So we make those substitutions. And so the 1/3's on the outside. The black integral. And then we replace 3x squared dx with du. And I'll replace the square root of u with u to the half. I'll bring the u to the half to the top, and I'm going to go one color now, okay? And everybody, this integral we should all be able to do because it falls into our rule. U to the negative half. It's just u to a power. So what do? Every time we take the antiderivative, add 1, right, and divide by the new coefficient. So you have your third, and then you have u, negative half plus 1 is half, divide by the coefficient, which is half. All right? And all right, that's our derivative. You flip the half up, you do some math, right? 1 divided by half is 2. 2 times a third is 2/3. And then you have u to the half power. Guys, do we all agree half power of u is a square root? But what's u? U is x cubed minus 4. Everybody, if you want to be sure you're correct, simply take the derivative of that. you'll notice if you do take the derivative of that, you will get the original black problem here. All right? That is integration by parts, okay? It's u-substitution. All right? The last one, Krista asked that, guys, because I want to make sure we realize that when we have a rational function, this is a rational function, it is continuous everywhere except one point in this case. It is continuous. This domain is element of all reals except x cannot equal -3. Do you guys all agree? We know a rule about limits. When a function is in its domain, I don't have to factor this. I don't have to think about this. That when you have a polynomial or a rational function with a domain, if the number we're looking for is in the domain, and it is, we just simply have to plug it in. 3 squared is 9, plus 6 is 15, plus 1 is 16. 16 over 6 is the answer. I would expect you to reduce this to 8/3. Do the math right. Everybody, that's all it is. I wouldn't expect you to factor this into x plus 1 times x plus 1. I don't even want you to spend the time. We check the denominator, we think about the domain, and we just go. Everybody, if I said -3, you'll know that this would be something approaching infinity. All right? I didn't want to do that today. What I do want to do is a related rate and an optimization problem. So I'm going to pause this video and start a new one.